Good morning, students. Myself, Dr. Shantani Bhattacharya, Assistant Professor of VC Department, SRM Institute of Science and Technology, Katankuladu, Chennai. Today, I am going to start a new topic, De-Multiplexer. Okay. So today I'll cover what is De-Multiplexer, what are the different types of De-Multiplexer, 1 to 2 De-MUX, 1 to 4 De-MUX, and its applications. So, what is de-multiplexer? De-multiplexer, in the case of de-multiplexer, there is only one input line in number of select input lines, or you can say control input line, and 2 to the power n number of output line. So, if there is a 2 number of control input or select input, then output line will be 2 to the power 2, that means 4. If there is a 1 is actually the select input, 2 to the power 1 means only 2 is the output. Okay, so demultiplexer is a single input and multi output combinational circuit. The information is received from the single input line and directed to the output line. Basically, based on the control input, it actually select which, basically it controls which output line basically the input will go in. That means, I mean to say, actually control input controls the input where actually go in which position of the output. Okay, and it is actually opposite of the multiplexer. In the case of multiplexer, what I have seen in the multiplexer video, if you didn't check the multiplexer video, then please go and check my multiplexer video. In the case of multiplexer video, here actually number of inputs are large, then output will be only one output. Okay, but in that case there is number of input is only one, but output is so many outputs are there. Okay, so here is actually de-MUX different types. 1 to 2, that means select input is 1 and output is 2 to the power 1 means 2. Select input is 2, then 2 to the power 2 is 4. Okay, select input is 3, 2 to the power 3, output is 8. Okay, select input 4, so output is 2 to the power 4 means 16. Okay, now we are starting the 1:2 demultiplexer principle. Okay, so here this is the block diagram. You can see there is a single input A and one select input S and two outputs Y0 and Y1. So based on the select input or control input, it actually depends, the input will go to the Y0 or Y1. Okay, so now this is the truth table. Truth table S is two combination 0 and 1. When input is 0, then only the output, that means when select input is 0, then only input line, that means A will go to the Y0. When select input or control input is 1, then input A is input A will go to Y1. So according to this, there are actually different inputs are there. So Y0 will be S1 bar or S bar A, and Y1 is S into A. Okay, so according to this is the logical expression of the output. So based on this output, we have to draw the circuit diagram. So this is Y0. Y0 is actually S bar A. So S, this is a single control input. Through it is NOT gate. This is S bar. S bar is one input and another is A. This is the first AND gate. This is output is S bar A, Y0, and another is S into A. This is Y1. Okay. So how it works? When S is equal to 0, you can see only this AND gate works and this AND gate will not work. Just look at the that means deeply you can, if you see that when S is equal to 0, then passing through the NOT gate it will be 1 and there is another input is A. So output will be A. But in that case, if S is 0, then AND gate one input is 0, and all of you know, if one of the input of the AND gate is 0, then output will be 0. So then only you can easily understand that if S is 0, only the output will go at the y0. Okay, I mean, we can see the output from the y0. Okay, so when control input is 1 or select input is 1, at that time if we consider this AND gate, it will not work because it is 1. So after this NOT gate it will be 0. So this AND gate will not work. Only y1 will work. Okay. So at that time A will go through y1. Okay. At that time y2, when that means y0, sorry, y0 will not work. Y1 works. Okay. Now coming to 1:4 De-MUX. Okay. 1:4 De-MUX. Here there are two select input. As it is two select input or control input, so 2 to the power 2, that means 4 outputs are there, y0, y1, y2, y3, and there is a single input, data input, that means A. Okay, so this is the 1:4 De-MUX block diagram, and this is S1 and S0 are the control input or select input. S1 is actually MSB, S0 is actually LSB. Okay, this is a truth table, S1, S0, 2 bit, so 4 combinations, 0001, 1011. So you can see when 00 combination is there, only data, that means input data is transferred to y0. When 01, then it is transferred to y1. When 10, then data is transferred to y2 output, and when 11 combination is there, data is transferred to y3 output. So based on this, the output will, we have to write in this way. Y0 is actually S1 bar, S0 bar A, then Y1 is S1 bar, S0 A, Y2 equals to S1, S0 bar A, and Y3 is equal to S1, S0 A. Okay. So now circuit diagram, so based on the outputs, so we have to draw the circuit diagram. So this is the circuit diagram, how to draw based on the equation. All of you just go to my logic gates videos. There we have clearly explained how to draw from the expression by using a logic gates any expression. Okay, so so this is the circuit diagram of the 4:, that means 1:4 De-MUX. Okay, so now I am talking about the how it is basically works. That is working principle. Okay, so in this condition we only concentrate on two, just I am taking two example. Okay, just we are taking S1 S0 first. Okay, S1 S0, now we are taking 0 1. Okay, 0 1 combination. So 0 1, that means they are telling that only y1, that means y1 we will get the output. Okay, 0 1 means, just look at the truth table, 0 1 means y1, from the y1 we will get the data. Okay, so how? So just see that 0 1, so this is y1, so y1 output. So 0 1, it is 1 is here, this line is connected to A. Okay, this line is connected to S0. Okay, and this line is connected to S1 bar. Okay, so here is also, this is S1 bar and S0. So if it is 0 and if it is 1, 0 means it is passing through NOT gate, then it will be 1, then one of the input of this y1 is 1. Then this is actually S0 is 1. So this is directly connected to this AND gate. Okay, and another input is A. So you can, if you concentrate on all this AND gate, you can see only these AND gates all inputs are high. Okay, but if you see other AND gates, or any one of the input will be 0. So in any other output we will not get any output. Okay, only from the y1 we will get the output. Just look at this. Okay, at that moment we will consider again this one. Okay, so this line is connected to A, this line is connected to not gate, that means A0. At the moment A0 is 1, so it is passing through not, that means it is 0. So as it is 0, that means this AND gate output will be 0. Similarly, here if we consider that this line is connected to A, this line is connected to A0 bar. Okay, so A0 is 1, A0 bar will be 0. So this is also 0. Similarly, if you concentrate on Y3 also, you can see that one of the input of Y3 will be definitely 0. So output will be 0. So when 0-1 combination will be there, then definitely only input data will transfer to Y1. Now we will consider another combination 1-0. Okay, that means S1 equals to 1 and A0 equals to 0. Then only we will get the output from the Y2. That means Y2, first of all we concentrate Y2. So this line is connected to A and this line is connected to A0. A0 at that moment is 0. So A0 is 0, so it passing through NOT gate, so it is also 1. Okay, and S1 is already 1. S1 is directly connected to this. Okay, so in the case of Y2, all the inputs are high, so we will get the input at the at this output Y. Okay, if we concentrate similarly like a previous one, we can say that all other AND gates input, any of the input will be definitely 0. So for this purpose we will get only the output from Y2, we will not get the output from Y3, Y1 and Y0. Okay, so now this is the application, like just at that moment consider this is a single input, this is a computer data will transfer to laser printer, fax machine, cooler inkjet printer or pen plotter. Okay, these are the outputs D0, D1, D2, D3, and based on this combination, when 00 will be there, 00 control signal will be there, then computer data will transfer to D0. When 01, then computer data will transfer to fax machine. When 10, then computer data will transfer to color inkjet printer. When 11, then computer data will transfer to pen plotter, in this way. And finally, main applications areas is communication system, arithmetic logic unit, then serial to parallel converter. And last, thank you so much, keep watching my video. If you have any doubt, then give this doubt to the comment section. I will try to solve this doubts. Thank you so much, keep watching.